to 9.7 homework problem number 1. So let's see. Betty works a maximum of 20 hours per week programming computers and tutoring English. She receives $15 per hour for programming and $10 per hour for tutoring, and she wishes to work between 3 and 8 hours per week on programming, but always to give more time to tutoring. And our goal is to maximize the amount she earns. We want to know how many hours she works on each job. So let's look at our constraints. So for our hours constraint, we know that the combination can be up to 20. So let's define x equals number of hours programming and y equals number of hours tutoring. Then we know that the total hours, or x plus y, must be less than or equal to 20 because Betty can't work more than 20. She can work up to 20. If you want to rearrange this a little bit so we can graph it better later, if we subtract x from each side, we'll get y is less than or equal to 20 minus x, and then we can put it in slope-intercept form and make it y equals less than or equal to, switch the x and the 20, negative x plus 20. So that's probably the equation we will want to graph in that form. Okay, now let's look at our real-world constraints. So we've dealt with the maximum of 20 hours. We'll deal with the profit later. She wishes to work between 3 and 8 hours each week on programming. Programming is x, so x has to be between 3 and 8, or 3 is less than x is less than 8. She always wants to give more time to tutoring, meaning that tutoring, which is y, will always be greater than x. What else? Usually zeros come into play. We know y has to be greater than x, and we also know that x has to be greater than 0, and y has to be greater than 0, because she can't work negative hours. So that doesn't make sense. Almost everything with the real-world examples will always have x and y greater than 0. And then let's think of our profit. Our profit equation, she receives $15 per hour for programming, so that's 15 times x, and, or plus, she receives $10 per hour for tutoring, so plus 10 times y. So now let's graph. If we look at this equation first, y is less than or equal to negative x plus 20. We have a y-intercept of 20. Slope of negative 1, so down 1 over 1, down 1 over 1. It's really just going to go all the way down here. See if I can draw a decent line here, and it will be dotted. Oh, I got screwed up somewhere. Erase and try that again. Can't really use a ruler on this very well, so. Okay, now I'll connect those with dots. All right, and so then let's look at 3 is less than x is less than 8. They'll just be vertical lines at x equals 3, but again, not included, so we'll make them dotted lines. And then y is greater than x. So this is really just like the line y equals 1x, which is a y-intercept of 0, a slope of 1. So up 1 over 1, up 1 over 1. This ends up looking very similar to the line we already drew. Okay. X is greater than 0 and y is greater than 0 is really all already included because we only have positive x and y values in there, so we don't really have to worry about it. Then let's look at where we end up shading. So our enclosed area, right here in the middle. And then our points of intersection we have are 3, 17, 3, 3, 8, 8, and 8, 12. So looking at our constraints, 3, 3, and 8, 8 will not work because x is not greater than y, or rather y is not greater than x. So we don't have to test those. So we'll use 3, 17 and 8, 12 and see which results in a greater profit. So for 3, 17, our profit, well, looking over here, it's 15 times our x value, which is 3, plus 17, plus 10 rather, times our y value, which is 17. If you multiply this through and add it up, you get $215. For the point 812, our profit is 15 times our x value of 8, plus 10 times our y value of 12. Again, we're using this original profit equation we came up with earlier. This ends up being $240. Since $240 is higher than, or a greater amount of money than 215, to maximize profit, Betty should program for 8 hours. That's our x value. And tutor for 12 hours. That's our y value.